Days that consist of 24 hours and years measured by 365 days are pretty standard units of time for us here on Earth. But on the planet closest to the sun, time takes on a whole new meaning. Just how can that be? Find out next on Real World. The sun's pull on Mercury has actually slowed down the rotation of this small planet. As a result, one full day, that's noon to noon, takes about 176 Earth days. A day on Mercury would last 4,224 hours. That's a long time to be in school. So, what else do we know about Mercury? It's the closest planet to our sun, and like Earth, it's terrestrial. Its temperature ranges from a scorching 427 degrees Celsius when the sun shines on the surface to a frigid negative 173 degrees Celsius on its night side. In many ways, the surface of Mercury is much like that of our moon, heavily cratered and old. But for everything we know about Mercury, we have even more questions. Let's talk to Peter Bedini from the Johns Hopkins Applied Physics Laboratory to find out what makes Mercury so mysterious.
There are several things that confuse us about the planet. It is very dense to begin with. We don't know why. It doesn't have an atmosphere. There's so few particles in the environment that they call it an exosphere. And it's tenuous. It's wispy. It sort of moves a lot. It's very dynamic. Mercury has a dynamic magnetic field like Earth, but smaller. And that's very unusual for a planet of that age. You'd think that magnetic field would be gone already. It also has signs on it that there was volcanism on the planet, so there are a lot of mysteries about the planet.
Mercury's position so close to the sun makes it difficult to study. Not even Hubble, our most powerful space telescope, can look at Mercury without permanently damaging its optics. So, how can we learn more about this unusual planet? Only one NASA spacecraft, Mariner 10, has ever visited the planet Mercury. Mariner 10 was programmed to fly by Mercury 3 times and take images of the heavily cratered surface. Unfortunately, the spacecraft essentially saw the same side of the planet on each flyby. Scientists and engineers spent the next decades developing new techniques and designing a spacecraft that could survive the extreme conditions of Mercury. NASA's MESSENGER mission is the result of their work. MESSENGER, or the Mercury Surface Space Environment Geochemistry and Ranging, is the first mission to Mercury in over 30 years. MESSENGER completed 3 flybys of Mercury, capturing stunning, never-before-seen imagery of the surface, before eventually inserting itself into orbit around the planet. A neat navigational technique that MESSENGER used on the way to Mercury was the use of solar radiation pressure, or solar sailing, to guide the probe's trajectory.
We realized that by changing the angles of our solar panels or tilting the body and exposing different surfaces to the sun, we could actually affect what path the spacecraft takes, and we can tweak the trajectory a little bit. The biggest savings that gives you is that you don't go through the risk of operating your thrusters. Whenever you do that, it's always risky with a spacecraft. So by using solar sailing and just sailing on the solar pressure like a sailboat does in a wind, we were able to direct the spacecraft where we wanted it to be.
And now that MESSENGER is in orbit, the spacecraft will allow us to observe Mercury as it has never been seen before.
We'll be able to characterize all aspects of the planet, from the inner core to find out if it's actually liquid or solid, and if it's dynamic, maybe that's the source of the magnetic field, to the composition of the surface by using a camera system that takes pictures in 11 different colors, and by looking at the different colors you can tell the composition of the surface. We have a gamma ray, neutron spectrometer, X-ray spectrometer that can tell the different elements that make up the surface, and we have a magnetometer, of course, to measure the magnetic field and characterize it.
But why bother studying Mercury? How will knowing more about this planet affect us here on Earth? A family portrait, one of MESSENGER's newest contributions, helps us answer that question. The 34-image mosaic of the solar system gives scientists a snapshot of neighboring planets from Mercury's perspective. These images help us understand that Earth is a part of a planetary family formed by common processes.
The way I think of it is that the solar system is like a large laboratory, and it has in it a lot of planetary bodies very similar to Earth's. Mercury is just one that's one of the more elusive ones that we're now going to fill in that gap. It's sort of an extreme case of the terrestrial planets. It's closest to the sun. It has these features I mentioned, like the magnetic field, high density, and by learning how it evolved and knowing what we know about the other terrestrial planets, we can learn a lot more about how Earth itself evolved, how it came to be.
By gathering data about Mercury, we'll be able to gain some insight into our own history. And with the Messenger spacecraft helping us unveil Mercury's mysteries, who knows what astronomers will figure out before the next day on Mercury goes by. See you next time on Real World.